Good evening, everyone. Welcome to University Lecture on Civility 2018. My name is Eugenia, and I'm studying postgraduate diploma in education. It's my pleasure to be your MC tonight. The topic for today's lecture is Assembling Future, a social innovator's intriguing project. We are honored to have Dr. Marcin Jakubowski, founder and executive director of Open Source Ecology, to be the keynote speaker. Dr. Jakubowski was born in Poland and grew up in the US. He was originally a researcher on nuclear fusion, yet later on he became dissatisfied with his remoteness from the world's problems, and then he turned back to the earth as a farmer and social innovator. He founded Open Source Ecology in 2003 with a vision to create a collaborative open source platform. He has created a set of design blueprints for 50 industrial tools that can be accessed by anyone and be built at a low cost. That sounds insane, right? Nowadays in Hong Kong, we are putting more emphasis on technology and creativity. All schools are implementing STEM, STEAM, or even STREAM in their curriculum. Students learn to be makers who can create small gears with 3D printing or even build furniture themselves. But now, Dr. Jakubowski is even expanding the definition and people's imagination of DIY. Perhaps someday we can be proud to tell our friends our mobile phones, 3D printers, home use machines, or even our own cars are all built or made by ourselves. How fascinating and exciting it's going to be. So now let's welcome Dr. Jakubowski, our guest speaker, to share with us his journey towards actualizing the idea of open source ecology and his perspectives on the future world. Welcome, Dr. Jakubowski.
Thank you. Thank you. Okay, thank you, Eugenia. Is the mic on? Can everybody hear me? Are we good? No? Are we, okay, testing. Is the mic on? Yeah. Okay, so I'm glad to be here, so thank you for inviting me. And first of all, who's, show your hands. Who's seen my TED Talk before? So there's a few people. Okay, what I'll do is I'm gonna go through that initially and then update on the progress and why I believe that open source is important to our lives and why I committed my life to it. So with that said, let's start rolling. So please roll the video. So, got it? Okay. So hi, my name is Marcin. So I'm a farmer, technologist, born in Poland, and now in the US. So I started a group called Open Source Ecology. I gotta keep going. So we've identified the 50 most important machines that we think it takes for modern life to exist. Everything from an oven to a circuit maker, a tractor. And then we decided to do our own DIY version that can be built and maintained at a fraction of the cost. And we called that the Global Village Construction Set. So let me tell you a story about this. So I finished my 20s with a PhD in fusion energy, and I discovered that I was useless. So I had no practical skills. The world presented me with options, and I took them. I guess you can call it the consumer lifestyle. So I started a farm in Missouri. I got a tractor, then it broke. I paid to get it repaired. Then it broke again, and pretty soon, I was broke too. I recognized that the truly effective, low-cost tools that I needed to start a sustainable farm and settlement just didn't exist yet. I needed tools that were robust, modular, highly efficient and optimized, made from local and recycled materials, that were designed for a lifetime, not obsolescence. So I found that I would have to build them myself, and I did just that. And I tested them. And what I found was that industrial productivity can be achieved on a small scale. So then I published all the designs, instructionals, diagrams, and budgets on a wiki. Then contributors from all over the world began showing up, prototyping new machines during dedicated project visits. So far, we have prototyped about 23 of the different machines, and you can say we're about 33% done, and then the project began to grow on its own. So we know that open source has succeeded with software and the tools for managing knowledge and creativity. And the same thing is happening with hardware too. Now we're focusing on hardware because it is hardware that can change people's lives in such tangible material ways. If we can lower the barriers to building, farming, manufacturing, we can unleash just massive amounts of human potential. And that's not only in a developing world. We have seen lots of excitement from the American farmer, builder, maker, entrepreneur, who can now start a CSA, community supported agriculture, parts manufacturing, or sell power back to the grid, all kinds of productive activities. So our goal is a repository of published public design that is so clear, so complete, that a single burned DVD is effectively a civilization starter kit. So I've planted 100 trees in a day, pressed 5,000 bricks in one day from the dirt beneath my feet. And I built this tractor in 6 days. But from what I've seen, that is just the beginning. Because if this idea is truly sound, then the implications are significant. Better access to local production, localized supply chains, and a newly relevant DIY maker culture can make a transition past artificial scarcity. So that's what we're doing, just doing what we all can do to make a better world with open hardware technology. So now I'm committed to open hardware. Let's see, can we get the second part? So I have an absolute commitment to open hardware. I believe it's a way to solve a lot of the different issues in the world. But let me tell you maybe a little bit of my background. Okay, let's see the clicker. I think I can do this. Okay. Right, so let me tell you a little bit about my background, so where I come from. So I was actually born in Poland, and as far as I can remember, I thought about the good things that we can do with science. My father's a scientist, he's in molecular biology, my mom's a teacher, and yeah, with the amazing technology that we have today, I was thinking, yeah, I mean, we can solve all kinds of problems. I wanted to contribute something good to it, good to the world. But then at the same time, I was wondering, well, if we have this amazing technology where we can, go to the moon or space and even create artificial life forms, I mean, why isn't there prosperity everywhere? So that was a big mystery to me. And I thought I could do something about that with science. So I thought about the other side, like why is there so much deprivation still? So when I left Poland in 1982, I mean, I've seen a little bit of that. So that was back at the time, behind the Iron Curtain. These are tanks actually rolling down my streets of Poznań in Poland. It's not a parade, it's a real scene behind the Iron Curtain when times were a little rough. And for example, I would have to wait in line for hours to get food which was rationed. So definitely some hard times. But then things got better. So we moved to the United States at age of 10. I went to Princeton University, one of the top schools, ended up with a PhD in fusion energy at the University of Wisconsin. But then again, I got a little alienated, as I mentioned. So it turned out that the farther I went in my program, just the more distant I was feeling from making any world impact or something that I thought was really meaningful. So maybe there was one incident where I remember that really really made me notice that, because one time I went to a professor after school in his office hours, asking about some equation that we were studying about wave propagation, because I couldn't understand it, I couldn't picture it. So I asked him, well, what does this mean? How can I understand this? And he said, well, it actually doesn't exist. I just made it up. So at that point, I was like, wow, is this what we're doing at our higher institutions of learning? We're talking about things that don't even exist, but real issues do. And that bothered me, and I didn't, that changed me in a big way. So at that time, another thing happened that got me onto the path that I'm on right now. And that is actually, I met a guy at that time, around the same time, who offered this lifestyle engineering course so I ended up learning meditation, breathing, cooking, and so forth, which actually Rinpoche talked here 2 years ago, right? So he was talking about awareness and meditation as very powerful tools. Well, absolutely. So I meditate, an hour or so every day. It's changed my life absolutely. So I pretty much tuned out of my program on a PhD level. I was doing more just studying what does appropriate technology mean and starting to organize around the issues of sustainability, environment, and appropriate technology and regenerative development. Almost got kicked out twice. I failed my prelim exam. But because I could focus with my meditation, I did it. I ended up finishing anyway, and things were good. I ended up publishing a decent paper, and that was good. But let's see. It was an amazing experience. And I learned a few things during that time. I was studying fusion, and no, that wasn't the answer to the world's energy problems unless we invent some new types of physics, because in that game, you cannot get away from the radioactivity that it produces. But I thought, okay, well, what is really appropriate? What technologies are appropriate? I still wanted to do something good. And I thought, well, regarding fusion, it's great that it happens on a sun 93 million miles away, but maybe on Earth it's not a good idea. But at the same time, I thought, well, what about appropriate technology? What can be appropriate here? So I started thinking about things like solar energy, where, hey, did you know that currently the sun shines at the surface of the planet about 10,000 times more power than we use today, even in our wasteful society? Well, yeah, so what if we could trap that and work on solar energy? The pressing issue there is that we haven't figured out how to solve the storage issue for nighttime power. But come on, people, if we can go to the stars and create artificial intelligence, can we not solve that question? Yeah, absolutely. So it's a matter of what priorities we take as we go into the future. We have to ask ourselves what is appropriate and what is not. So also during the PhD program, I also ran into another friend of mine who actually for the first time showed me Linux, the open source operating system. So who here has used Linux? Anybody? Yeah, a few people. So it's not unknown. Linux has pretty much, or open source software has succeeded very well. No question about it. Linux now runs more than like 99% of the world's back-end infrastructure, so Google and Facebook and Amazon, they all use Linux on their back-end. Not too many people on the laptops, only like 2% are using Linux. But it's a well-known phenomenon. But that taught me one thing. It's like, wow, okay, so I saw this Linux operating system. You could just download it from the internet, put it on your computer, modify it, and customize it. You can download all the software that you want. You didn't have to pay for it. I thought, wow, that's a great idea. And at that time, I was actually using Mac because that's what my research group was using. But I thought, wow, that's interesting. There's things that you think are like religion, like Windows or Mac. But no, for any technology, there's options. And the point of open source is that you can access those options. People can get involved much more in the technology that they use. So the concept, I want to bring up the concept of technological determinism. There is no such thing as a certain technology is the best for us, or it's like inevitable that, oh, it has to be that way. At all times, it's a choice. So what is efficiency? Like for example, to give you an example, like if you've got a lot of oil in your background, you're probably going to think that gas cars are the most efficient. But if you don't own an oil field and instead you have abundant sun, you might say, hey, maybe solar energy is the most efficient route. So technology is totally context dependent. It depends on the political, social, and other forces that are in society. It's not a given thing, and we have a lot of power in terms of how we affect that and change that. So was another episode back at the PhD program that kind of made me think about openness. So this is still leading to open source ecology, how I came up with that. And believe it or not, in my research group, I could not talk openly about the work that I was doing. We actually had some hot material, some pretty innovative work, and I just couldn't reveal it openly to others. And I thought, wow, what a waste. It's like, we are at a public institution, like, isn't this all about transferring knowledge for empowering people? Knowledge is absolute power, and teaching people gives them power, but more than giving people power, knowledge empowers people to provide for themselves. So if we are depriving people of knowledge, that's not a good idea. I really felt uncomfortable about it, and I started thinking, what would it be like if we actually truly worked together on big, massive problems to solve them, to solve all the pressing issues in the world faster than they're created. So there's enough serious work that we can do and work on together that competing is just, that's no fun. But I noticed that, so at the last year of my program, I actually ended up coining or forming open source ecology and haven't looked back ever since. So now working on open hardware, which is something that most people maybe have not heard of. But so I got out of the PhD program, settled on this 30 acres of land in the middle of the US, in the middle of nowhere, Missouri, the state of Missouri near Kansas City, and began our open source hardware development experiment. An experiment to really explore things about how can we build a small civilization that does have a modern standard of living, but possibly do it better somehow. So one of the things that I definitely learned for me early on, it's like, okay, I learned the lessons about you need equipment, you need tools and techniques that I didn't really get, so I had to learn all of that. But when I built the first tractor, it was a completely transformative experience. So the things I learned was that, hey, it's actually not so hard. If you break down things into their components, you can actually understand them. Like, this tractor here is nothing but essentially a big box with wheels. I mean, it's got a basic frame, wheel drive. So you can break down technology into its modules in a way that you can understand it, and it becomes less intimidating. And especially if you are committed to it, because I had to make this work. I needed the tools for my own use. I was very much motivated to make it happen. And then I thought, okay, well, if I'm going to do this for myself, why not help others too? So the thing I did was publish everything, and I thought, okay, if I'm having this problem like this, I bet you there's many other people in the world that face the same issue. So publishing that would help pave the way for others. So for example, like these people in Peru replicated the tractor, they modified it, or students in Pasadena, California. So the package ended up being the whole global village construction set. I said, okay, let's do this whole set of infrastructure technologies. They're very important critical machines that would suffice to provide many needs in many, many, many places. But what exactly is open source hardware? So let's just get into that because to show why it's important. So open hardware is, it doesn't mean like open source does not mean that, okay, the thing is free, like software. There's materials, someone's got to pay for that. But open source means that the blueprints for how you do that are absolutely open. So you have the open source definition means that you can study, you can build, you can modify, you can make and sell that technology. So the critical part also being the sell part, because if it's about making livelihood, selling things can get you a livelihood. So just like open source software, people started getting jobs doing programming for companies, that many different companies hired early Linux programmers. There has to be a revenue stream that comes back to you so that you can survive. So we build things like open source plans for 3D printers. That's an example of our 3D printer. Open source hardware can apply to just about anything. Printers are quite common. People make open source satellites that have open source blueprints for them. Aerial drones are common examples. Laser cutters, our tractors, that's a picture of our tractor there. Or aquaponic greenhouses, that's the greenhouse that we have that's from our site, once again, where there's fish fertilizing those plants and we're growing plants. Or, hey, did that disappear? Yeah, that disappeared on us, but there was a picture of a house. So we can also build houses as well. So for example, we can build a 140 square meter house with 50 people in 5 days. So we're actually focusing on very efficient production as a means to do it. Now, hardware is so critical because it's actually like, there's a lot of talk about the Googles, Facebooks, and all that, but that's a very small fraction of the entire economy. All the software economy is about $2 trillion in the world. Hardware is about 20 trillion. So that's all the physical infrastructures. And then there's a big service sector, bigger than that. So huge economic impact. And we cannot forget that while software in some way runs our life today, no, we still eat and live in a house. And I hear houses are pretty expensive. But we need physical materials to survive. A lot of times we get the question, okay, but how do you make money, right? So the distinction has to be made if the blueprints are open. How do you make money? I get this question all the time. Well, if the blueprints are open, no problem. We have to differentiate between the concept of what open source is. It is not a business model. Open source is a methodology for developing things collaboratively, openly, so everyone benefits. Now, you still have to make a business model on top of that, just like software has to make a business model on top of what software provides. For us, the model can be production, can be selling kits, services, or other things. What we've developed is, so that's an example of our brick press. We can now build it with 12 people in 1 day. That's actually the first brick press that we built in just 1 day. So we're focusing a lot on the efficiency of the production. But the idea is we make a machine, we can sell that. We are actually selling immersion training programs, like where the people can go to our workshop and they can learn to do things like weld and build things. And they pay us for that, and we can also sell the product that comes out of that. So we call that extreme manufacturing because we're getting to extreme efficiencies. But really, we're trying to solve a much bigger question. If we distribute this production far and wide, we can address this equation. Does anyone know what this stands for? Can anyone say? Okay, well, 85 equals 3.5 billion. The 3.5 billion of the poorest people have as much wealth as the 85 people at the top of the pyramid. So that means a very skewed distribution of wealth. That figure is actually not improving. Actually, in 2016, like last year, that figure of 85 of the world's richest people, it's actually to 7. So you can look this up. I'm not making this up. Google it. But this is the reality today. There's huge disparities of wealth, and that's an important question. So we focus on what we call the one-day extreme manufacturing workshop as a way to do it. So some of the learnings that I also got from of these experiments with building things, at 2011, I got to the TED Talk, made it to the world stage. It was great, got a lot of interest from many people offering to help. I thought we were going to be done in like 2 years when it was 2011 with all of that. But no, it didn't happen. It was found that it takes much more solid effort and organization. Basically, the distinction between vision and entrepreneurship. There's a huge gap there, and anyone trying to make a big difference, you're going to be in for a deep dive in learnings because things just don't happen like that. So right now, our current plan is to finish by 2028, so we're giving ourselves about a decade to finish all the other tools of the Global Village construction set. So yeah, big learnings on my side, that to transition from the vision to execution, you have to start with basic principles of what business is about. So you have to have your team, management, entrepreneurship. You have to have your projects and budgets and all that. So that's part of the game, and that's where the efficiency actually comes in. So we're learning how to create this open source collaborative process and leveraging the fact that a lot of people can come together at the same time and create efficiencies that way. So we address the question of production, education, like a social productive process in one, and make that work. Now, how do we make it work? So for one, you have to have pretty good instructionals. Documentation is a pretty hard part here. So we draw up things like these IKEA-style fabrication diagrams, for example, for the brick press. And then we put a big team of people together. You have to lay out the workflows and everything very carefully. So here we're building a house. Like, okay, that disappeared on us too. But we built a house, just a micro house, kind of about 200 square feet, 3 days with about 20 people. So we're learning how to get efficient. Now this one, that's 140 square meters. We built that with 50 people in 5 days. So that's getting towards some pretty decent efficiency, and therefore the possibility of a viable economic model. Right now, for example, we're working on a pilot project, taking this small tractor for basic mechanization in Ghana, and we're going to take 50 of the locals, and we're going to guide them to build this thing in just 1 day. So that's great. That can be, if we can do that, now that's a definite milestone. That is economically significant because it's replicable. You create enough value in a day to make it happen. And what are some of the other keys to this? So in order to make something like that happen, you have to break things down, the technologies down, into modular components. So this is how we do it. Like we take the 50 different machines, we break them all down into about a dozen or so modules, and then for each module, we develop about 40 or so different development steps. So it's a large process. Just like Linux has succeeded with software, you can break software into many, many parts, so it's doable there. Exact same thing applies to hardware. And for the different development items, you've got, first of all, your requirements. You go into like the conceptual design, then your technical design, then your blueprints, build documentation, build data, testing, and so forth. So you go through that process, but the deal is if you can break down machines into their own modules, then you can do a massive parallel process of development like this. And we found that it works. Now also just the economics. So we're finding out some cool things that, yeah, these things work. So just to give you some numbers, the machine like this brick press, which produces about 5,000 bricks in a single day. So these are just compacted earth bricks for building houses. You can put stabilizer like cement in there, so they're also waterproof. And it's a high-performance building material that's both good for natural building and more advanced industrial-style building. But a machine like that would cost like $52,000 from the nearest competitor. For us, it costs $5,000 in materials. When we sell that in a workshop, we sell that for about $10,000, which means about 2 times the cost of materials. So a person comes to our workshop, we build it in a day, and they can take it home. And then we also charge people for the tuition. So say there's like 12 or so people that sign up for a workshop like that, or 12 to 20 or so. We charge them like $300 for like a weekend or so. We can walk away with net of like $10,000 per event of building a CEB press, compressed earth block press. So there are viable economic models to do this. This is the particular one. We're choosing the idea of extreme manufacturing, the one-day builds, immersion training kind of experiences. So that works for the big machines. We can do the similar thing for 3D printers. So we can build 12 printers. I can guide a build where you can build and take your own 3D printer home with you after a day's workshop. And we charge, once again, like $300 above the bill of materials. So if 12 people sign up, we can get like $3,600 from that event. Or doing the much bigger things like the Seed Eco Home or aquaponic greenhouse. Both of those items were built in 5 days with a group of 50 people. So in that case, it works We charge people for the tuition. We got 50 people to sign up at $500 for that 5-day thing. So we got $25K revenue from a 5-day workshop. And then if we have a client who actually buys that house, our basic model would be to sell it for about $70,000. So material cost in a house like that is $30,000. So we're talking about $40,000 on top of that for all the preparation, all the work that goes into that, plus about the $25K from the tuition. So there's definitely a viable business model there where still for $70,000 for a house like that, I mean, that's amazing. I mean, it's at least 1/3 the cost of industry standards. Like where we are, where there's hardly any people there, but a house like that would probably go for like $250,000 or so. So our goal is to produce turnkey housing for people at 1/3 the cost of industry standards. So that actually works. But this open source economy, in effect, actually is hardly known to anybody at all. Like this is not entering people's consciousness. If you gather up all the open source hardware projects out there, they hardly exist at all. It's like 1/1000th of 1%. Probably a total of about $100 million worldwide that's embodied in open hardware projects. Everything else is pretty much proprietary, thinking about it that way. So for all practical purposes, most people have not heard of open source hardware. And there's many challenges why open hardware is much harder than software. So if you compare that, that's Linus Torvalds, the developer who brought about Linux. He got to the cover of Wired magazine for doing that. But in an open source software case, it's much easier than hardware. So in open source software, all you have is people programming on computers. So it's not very capital intensive. It takes your time and a few electrons, some electricity to do that. But for hardware, I mean, you've got the whole manufacturing part. How do you build it? Your workshop, your tools and materials. A lot of different resources that are needed. For software, it's also that the history of software actually started open source. Early on, when software first started coming out on the mainframes, people shared their code. So the culture of sharing is actually well known in software historically, even though it got pretty proprietary, like with the era of Microsoft and everything like that. But today, recently I went to the Open Source Leadership Summit, and everybody's talking about open source software, like Apple, Google, Microsoft, Facebook. They're all there, and they're all supporting open source projects because they know that it makes economic sense. They know that it's easier to collaborate than to develop all the code separately because they can easily form business models on top of that open core of software. For software, it's also easier to build that than for hardware. Hardware has much more logistics and complications involved. Now, software is also much more recent than hardware, because if we talk about hardware, we have to go back all the way to the Industrial Revolution when it all started. So at that time, patents started coming in. People wanted to protect their investment in research. So throughout the history of human technology, which means the industrial age and then the information age after that, everything is quite proprietary. So for hardware, it's like people just don't know that open source is even a possibility. Now, hardware also requires a lot of documentation. It's hard to document. If you're building something, it's hard to just stop and write things down. But we pay attention to that. But we do recognize that documenting is very, very difficult in hardware. Whereas for software, it's kind of self-documenting in some way, especially if you've got well-documented code. You write comments in there, so you document it as you go along, so it's much easier. But we actually did find out some good ways to document by involving people remotely through Google Hangouts. We can actually now generate a build, like for example this ironworker machine, working on a machine that cuts metal. But by involving people remotely, we can actually get an instructional produced at the same time that the technology is built in a workshop. So that's pretty good. So we figured out how to do that. Definitely there are huge cultural barriers to open source hardware, though. I mean, we're just not wired to do that. As I said, most people actually believe that proprietary or the patents are like a law of nature. Just some people think think that they don't recognize that it's about like what the distinction is between things that humans have created and things that are because that's what nature says they are. I mean, patents and the proprietary way of doing things is just a human construct. And it's not the way it has to be. The patents came about because companies invested a lot of money in development. They had to hedge their risk. The way they did that is by getting patents and a temporary monopoly on cornering a certain market. That's their business model. But it doesn't have to be that way. In open source hardware, the way it works is because there's a lot of people developing that, your risk is mitigated for the development cost because it's all shared by a large number of people. So the patents are an option. It's just one way of doing things, and we don't believe they're the best way to do it. But collaboration, mentally, like psychologically, it's not that easy because most people are not really used to it. Even in the workshops that we do have, like when we run the extreme manufacturing workshops, we always have people that are either slower or faster. So like for the faster people, a lot of times they're like just racing ahead. They kind of don't pay attention because they think they know everything. They actually end up making a lot of mistakes and not finishing any faster. So, but the fast guys, they don't want to help anybody, just want to race along. And then the slow guys, actually, they kind of are a little shy about asking for help because they might feel that they're dumb or something like that. So what we do in our workshops is we actually force everybody to work together. We coerce them, saying, hey, fast guys, don't go ahead. Actually, as soon as you're finished, go help the people that are slower. And we're telling the slow people, hey, it's okay if you're slow. We're here all to learn together. And therefore, everyone learns more in the process, and everyone's happier, and actually more gets done when we collaborate in that way. But I do recognize it's pretty hard because we're simply not used to the open collaboration in many ways. So at this stage, so we keep on going. Let's see, how am I doing on time here? Is anyone keeping track of time? Or no? We're good? Okay, so anyway, one of the things I wanted to bring about on this mission of developing the Global Village construction set, it does take a lot of perseverance but that's by definition. If you're going to try to do something big, by definition, it's going to take a long time. No, it didn't happen those 2 years like I thought a long time ago would happen. But you have to be ready for that when you're learning and when you're open to learning, you're going to fall and then get back up, and it's all about perseverance. So how do you do it? It's, for me, the things I can share with you is that it's really important to do what you're absolutely passionate about and believe in so that you can follow the true drivers of what makes us happy. And what is that? It's been defined in self-determination theory. So self-determination says that the most important drivers of human behavior are autonomy, mastery, and purpose or relatedness. So doing the things that are most meaningful to us. Mastery is about always learning and growing. Autonomy is our freedom to do what we want that's most consistent with our inner drive, what we really want to do. And purpose is doing something greater than ourselves. So if you've got those ingredients, you can keep going. I'm completely motivated by what I do, and it's going to be just a matter of time before we do this. But self-determination says that it's not going to be that carrot on a stick that's going to drive you. It's going to be much deeper human desires of having meaning in one's life. I must also say that when you also connect to being productive, like with your hands, doing real tangible things, that's a kind of connection that a lot of people have lost in our virtual world of today. But it's also something that's deeply wired in us, and I think a lot of people feel quite alienated from the world or powerless because they do not have that kind of connection. Because ultimately, that connection is to the very resources that feed us. Because all the wealth that we currently enjoy today in our modern standard of living comes from rocks, sunlight, plants, soil, water. I mean, all those are the abundant resources, and then it takes energy and know-how to process them. But they're also made, in our productive mechanism of today's society, they're made scarce, and artificially so. And part of getting past that artificial scarcity, it's an artificial scarcity. I mentioned about the 10,000 times more power from the sun that we use today. That is, we have abundant energy to convert the abundant materials around us to the life stuff of modern civilization. So if we connect to being productive, we're actually connecting back to nature. So I would actually say that the deepest form of environmentalism is where you learn more about technology and understand that everything that we do use comes from nature, and therefore we have to respect nature. We have to take care of it. We cannot ruin the environment or what's all around us, because that's what feeds us. So that kind of connection has to be real in people for us to be, I think, psychologically healthy. So vision is the second thing. So seeing that the first tractor that I built, maybe it doesn't look pretty or whatever, but I built it myself, and I see that, okay, that's just the first prototype. There will be more, and it always improves. So I don't see like our farm as, okay, look at all those weeds growing there. I don't see a weedy wasteland like, initially when some people might say that to me, but no, I see a luscious orchards of the future dripping with fruit. I mean, because that's what we're doing. We're investing for the long term. We're planting trees and other things. So it takes vision to say that, okay, you're making progress and you're doing better with time. So how do you also persevere? I do believe that being healthy is also required for having any long-term vision. So what is health? I mean, health is you're getting enough sleep, having a good diet, getting exercise, also being psychologically healthy, fulfilled in what you do. So that's mental, physical, spiritual health. If you have that kind of balance, yeah, you can go through a lot, because I think that's a foundation. I mean, our bodies are connected. We're connected to our bodies. If our bodies don't work, we can't work psychologically either, and the other way around. I mentioned the great empowerment from doing real things. So another great motivator that drives me is the service to the world. We're doing work that we think is good for the world. We're giving to the world, and that's a really fulfilling thing on the inside. So with that kind of an approach to work, you cannot go wrong. It always requires growth, a willingness to learn new things. The worst terror in our line of work is people who think they know everything, because that means they stopped growing. If you think you know something, then you think there is no more. But you always have to ask for what else is there. Is your mind open to things that you do not know? Because everything is, you can look at, it's either, you can get intimidated by some situation or take it as an opportunity for learning. That's nothing new. And also Rinpoche, in his 2016 talk, I liked one thing he said, that we have to have the mindset or vision to not look at those, like for everything, there's like 9 things that are going right, maybe 1 thing is going wrong. And we tend to think of that one thing and focus on that one thing that's going wrong instead of thinking of all the good things that are going on. So keeping a perspective is also very important. For us, so we're going to keep working on this Global Village construction set, but I also said to myself, okay, in 2028, I'm retiring for the next time. I already retired after grad school, but what I mean by that, no, it's hard work, but I love it. So in 2028, we're going to shift to the next level. And what is that? So talking more about what it means to grow as a person, so human development, what we call integrated humans, people who are physically, mentally, spiritually integrated, because right now there's a lot of disintegrated people. I think in a world of today, most people kind of lose touch with themselves, and there's a lot of mental anguish, even though we are so prosperous materially, in America, you know, it's excess and there's still deprivation. So anyway, in 2028, we're shifting our gears from technology, which we're going to get this thing done by 2028, open sourcing the main productive mechanisms of society, and then focus on human development and also governance issues. So there's a phase till 2028 that I invite you guys, everybody here on. So how do you get involved with what we do as we continue on the hardware and then focus on more societal issues? So scan that. That's the page here. But one thing we're doing right now to involve other people is starting OSE clubs in different locations. So we just succeeded in getting the London International Academy in London, Ontario on board with collaboration where we're going to work on an open source microfactory, doing things like the 3D printer, plastic recycling. So that means shredder and filament maker. So you can take plastic scrap and convert it back to 3D printing filament using our open source filament maker. So that's a collaboration. But we're inviting different clubs around the world to collaborate with us. Basically, the thing is finding students that are interested to do this development work and collaborate in a much greater vision in that we're all doing the work collaboratively in different locations around the world. We would hold, like every quarter, every few months, we would hold like a design incentive challenge where we come together and prototype the designs that we do. So it's both online and then meeting together in a location. But we'd like to develop a number of these chapters worldwide where we can do that together. Online we are, so look at the workshop interest form. So we're running workshops on all the stuff that we do in different locations. So if you want to request a workshop near you, sign up there, put yourself on a map. That's a map where you express that you're interested in a workshop. We also started our first ever immersion program. So just September, we had a month of immersion training where we trained a few people, 3 people to run the workshops. Right now we just started with the 3D printer workshop. So we taught 2 people now are working with us full time, running the workshops actually in California, back in the United States. So we're training people to actually get livelihood in this work. Because once again, it's about livelihood. If it's part-time, you know, you can only get so far, but we do recognize that you really need to get paid for what you do in order to stick with it. Because we've seen a lot of turnover with a lot of volunteers, but we'd like to get an operation that's much more stable. So that's the immersion program, work with OSE. So if you have more money than time, you can donate as a true fan as well. So there's donation options too. But I think I will end up here. You can email me at marcin@opensourceecology.org. So if you'd like to bring workshops to your school, or if you'd like to join the immersion program, or start a club, or we do other things like along with the extreme manufacturing model, we can do other things like doing things like corporate team building retreats where you build some crazy machine and do it with a big group of people. There's continuing education programs that you as a teacher or a librarian can get involved with to get trained for professional development credit or other opportunities around the extreme manufacturing workshop. But yes, we share everything openly and we're looking for a lot of help in the next few years as we finish this thing over the next decade. So I hope to see you collaborate and maybe we can see what kind of collaboration can sprout with CUHK right here. And I'll probably be back pretty soon because China's got all the supplies that we are using right now. So, so I think I'll wrap up here, and thank you very much. And I'd like to open this up to questions.
Thank you very much, Dr. Jakubowski.
Yeah.
And thank you for giving us such an inspiring and insightful lecture and showing us that perseverance is always the key to success. And there are many opportunities for us to learn as long as we are willing to. So I believe our audience has a lot to ask. Now let's proceed to the Q&A session. I'm pleased to invite Professor Ng Mi Kam, the Vice Chairman of the Department of Geography and Resource Management, who is also the Director of Urban Studies Program, to be the moderator of this section. Please welcome Professor Ng.
you, Martin, for such an inspiring talk. I think, I jot down some sound bites, that I think is really wonderful. This open source hardware economy as a technology, I really like the idea of technological development as a means for us to have more options and choices. And in a way, the way that you run your workshop tells us that technology really is related to how we organize ourselves, the social relationships, and this idea of having people to really get together and solve problems collectively, I think is really a very important and wonderful idea. And I really also like the idea that we really should have a deep respect for the environment. That's where we learn how to make this technology even better. So I think that is also another aspect which is so good. And also, I'm a planner by training. Everything that, Martin kind of talked about reminds me that, it's so important for us as human beings to get together and have positive relationship and also do something which is real that can solve our everyday problem. Actualizing ourselves, as you said, right, is mastering these tools to actually help us to be more independent. So all these great ideas are just so wonderful. And having all these in one talk, I think is really worth your time to be here, I guess. So, okay, so I think I should stop here and let you ask whatever question you have in mind. Great. Yeah, at the back too. Okay. And there's one up front as well.
Thank you for your amazing speech. I'm a student in CUHK. So when I listen to your speech, actually we think that it has a large potential to bring social change because, one of the largest critics to capitalist modern society is that the means of production are dominated and we don't have control on our environment or on our living. So by open hardware, it might change the society. But the problem is, we would like to ask, how could we do that in the context of an urban place like Hong Kong, when it's very difficult to build something and it's much easier to buy something? And how can we make this open source hardware in a larger scale because we have to make it like an incentive more people to do it in urban society for it to make actual huge social change. Thank you.
Yeah, okay. So what can you do here? So in a lot of urban environments, you have the concept of a maker space or a hacker space. You do have one here. Actually, a TED Fellow friend of mine, Cesar Harada, he runs Maker Bay. So has anyone here, have you heard of Maker Bay, for example? It's a place with tools and a space dedicated exactly to what we're doing. So they run workshops of all kinds where you can get hands-on training. And I actually tried to get in touch with Cesar. I failed because he was busy traveling, but we are probably, he's actually open to me running workshops there, but that's definitely a great place to do it, a space like that. So any major city will have something like that. And the idea is that right now with the digital open source, there's a lot of digital technology, open source tools on a very small scale. They're affordable, cost-effective, like 3D printers, laser cutters, CNC circuit mills, routers, and other things. They're very accessible right now to things that before were doable by bigger companies and they were just expensive. Right now, they're quite low cost. And like, for example, the 3D printer, around 2010 or something like that, it happened that the patents on the technology ran out, so the open source RepRap project, it was called, open sourced the 3D printer, and since that time you can get a 3D printer for a few $100s, whereas before it was like $30,000 or so for a 3D printer by these large companies. So the ability to do things on a small scale is increasing. So if you have any space, like, I don't know if you have any space at home, maybe not, but take advantage of spaces that do already exist, like Maker Bay, or maybe the university facilities here, like at the library, they have a little hacker space with 3D printers and laser scanners and other tools, so you can start getting involved in the physical prototyping. Does that answer?
And how about the incentives for more people to join? Because people can't make their own stuff.
Yeah.
So they just buy it.
Right. It is way more easy, but what would it take to make this really accessible? I think that social environments where that's acceptable as like a group exercise would be great, but the real missing thing is also the blueprints. Like a lot of really useful stuff is just not really well available out there. So there's a whole thing that has to happen with open design, practical open design being really accessible. Like what you'll see a lot is that there's many open source projects out there, but also that problem of things going or disappearing or going proprietary is still an issue. Like a lot of times when somebody actually has a great, amazing product, they just make it proprietary. That's what happens a lot. So it's up to all of us here to make those open source designs available so that the best design is available to everybody. You can actually produce it. You can start a business producing that or something like that. So there's still a way to go because of that cultural barrier that people have. It's like most people are not aware of this, and the people who are good at this design, they tend to close it up as soon as they've got something good. I mean, I've seen that actually quite a bit. So that is a big issue. Yeah. Yep.
All right, so the next person.
Okay, thank you. I'm also a current CHK undergraduate, and it seems to me that, well, of course, it's a brilliant idea that we can build hardware ourselves, but it seems that in the recent years, software is becoming more and more dominating. For example, in the recent years, we talk about Internet of Things. Like even for very simple hardware like water bottle, we want to program it so that it will remind you where to, when to drink, or remind you how much water you have drank today. So it seems that we are implanting software into every hardware we have.
Yeah.
So I'm curious how you see this trend. Thank you.
Well, I think that's the idea of Internet of Things is a good thing because it's combining both worlds. So imagine you have open access to both the software and hardware. That makes it happen. Like automation, like for example, the tractor that we're building. You know, next thing would be to, for example, add autonomous control to it, or the fact that you can program it like an Internet of Things device. I think those two worlds coming together can move open hardware forward because more people will start finding out about it. They'll see, okay, well now you can control things with software that's everywhere available. Then the next thing is people will start noticing, hey, what about the hardware? We need open access to that hardware so we can modify it to do things like the Internet of Things. So I think both movements can help each other, definitely. Yeah.
So I saw a hand up here. I was told that.
Yep.
Yeah. I want to ask the questions about, you say your open source hardware project is a relevant project, but I think that in different countries, the raw materials and the labor force is different.
Right.
How can you ensure that the open source hardware project can be worked in everywhere?
Yeah. Yeah, and that's part of the definition of open source, which is one of the items is that you can modify it. So the idea is that every location in the world would make its own adaptations because the conditions are going to be different in every single place. You can have different people, different skills, different tools and materials, which therefore makes every single thing unique. So you have to adapt to a particular location, but that's perfect because if many people around the world are working on that, then individual groups can make it happen.
And
Yeah.
others is about a concern that after the people make the things by the open source hardwares, and how can you ensure the qualities of the product and the safety of the product?
Yeah. What's the first question? So there's safety and quality control. You're asking about that? Yeah. So in addition to the product designs, we have to think about what quality control looks like. And we call that distributed quality control. it's an experiment, but you can provide things like for example, let's give you an example. So we have documented how you can build our kit by getting parts off the shelf. So with that instruction set, we have quality control checklists and things of how you can quality control it yourself. But more than that, we can also certify people to basically through a certification process where they would submit the documentation of what they have built so that we can license them to actually build that to OSC specifications. So that's a current experiment going on, but I do believe that it's possible because on one side we make the design absolutely as simple and transparent as possible. We use other techniques like the things can fit only a certain way. That's a technique in manufacturing. And then you have the quality control checklists that people can learn about. So we're trying to distribute that quality control. If people are building this in different locations, on one side we can give them guidelines to do that and facilitate that process, ultimately ending with certification. You need some person or some people or groups, entities that are capable of doing that quality control, because someone has to do that. Yeah. Now safety, that depends on what you're dealing with. A lot of times the disclaimer is if you're building this yourself, you're assuming the responsibility that you learn what it's laughter, that what it is to do that. So that's why we're trying to create the support infrastructure for doing this. So one is spreading out, hiring people in different locations to run the different workshops and therefore being able to be qualified to do the quality control in different locations. So that's a big issue, but it has to be addressed. We're not addressing in the fact that, okay, one factory has it and you've got this one quality control line doing that. Somehow you have to build that into the process. And how do you do it in a distributed way? It's harder, but I think it still could be possible, especially when you have different support networks. Like say one region somewhere learns to do that really well, it will develop its own quality control mechanisms. But also we have to provide that guidance to first document like what are all the things you have to do and things like that. So.
Thank you.
Yeah.
Right. Any other questions? Okay. Shall we have? Oh, you're next. Yeah. Okay.
Okay, thank you. So I have two questions. Firstly is you say that all of your project is done by yourself at the very first beginning. So I quite wonder how do you gather the first group of people to help you to so that you can develop this project to this day?
Yeah.
And
yeah, I mean, so initially it's like, you got to start somewhere, so you got to, kind of start yourself. But how it grows is if you publish. So all you got to do, just start a blog and start taking videos and documenting everything that you do. What you'll find out is that pretty soon people will look at that and say, oh, wow, cool. If you're spending the time to do the documentation and public outreach, it will start happening. So then, do the YouTube videos and everything else, and to the point that at some point, important people will notice and they will offer help. It's actually quite a magical thing that happens. You'll notice that you are not alone. There's, if you're communicating a message now with the internet that's available, you'll find that there's so many people that are in the same position. And that's what I noticed, and that's why I said, okay, well, if I'm having this problem, I was getting feedback that, oh yeah, a lot of people are having the same issue, and they were like, wow, yeah, let's work together on that. So it happens in a really nice way that, like, compared to like proprietary development that some corporation develops something, well, nobody's going to help them because they're trying to help themselves. So if you're actually giving to the world, it will come back to you. That's guaranteed. That's just how things work. Yeah.
okay, thank you. Another question I have is, did you face any legal issue? Because in your project, you have built quite a large-scale product, like vehicles or buildings. Because most of the case, let's say the vehicles with higher than solar power, they cannot be run on the streets or the buildings, and usually require some certified person to build it. Do you face this kind of legal issue, and how do you?
Yeah, how do you address that? So the first answer is that no, we haven't run into it yet, but it's coming. So what do you do there? Just like people take certification, like whatever CE or whatever I mentioned about OSCE certification, but we're going to have to go through, like say we have a, say we're going to be building a car. Well, we're going to have to go to through the crash testing and approvals to get that thing proven out. Well, just like companies do that and they have to spend money on it, we'll have to put the effort into that too. And we can also crowdsource that. Like, okay, we got this amazing car, now we're going to take it to testing, put that up on Kickstarter and say, hey, fund us so we can get the certification, so we can get a street legal certified vehicle as a result of that. You can do that through crowdsourcing too. So yes, you can, you have to do it, and you can also generate the public support to make it happen. Yeah.
So this gentleman and then the gentleman at the back. And ladies, please.
Yeah.
Okay. Oh, thank you very much. And I believe that you are still working on fusion, but it's the fusion of knowledge instead of.
Thank you.
Thank you. I have a quite practical and urgent question that because in Hong Kong now recently we have thousands of tons of fallen wood that will probably end up in the landfill. Do you think is it possible to build or to hold a one-day workshop to create maybe wood chipping machines? Is it possible or? Yeah,
Well,
and also what about the
absolutely.
safety concern? And because wood chipping machine is can be quite dangerous as far as I know. So can you demonstrate how can it happen? Yeah, for this urgent issue.
I love it. Well, first of all, the hammer mill or a wood chipper is one of the 50 machines. So that's a good start. But we don't have that design developed yet. But with about a month of development, we can get a prototype and a working machine. So, and after that, yes, absolutely, we can build it in one day. So if there's a need to do that for real, just invite me, I'll do it. I'm thinking like, wow, okay, so we use wood pellets to heat our house with. The pelletizer is actually one of the machines as well in the Global Village construction set. But yeah, like, would people buy? No, you guys are in a tropical country, so you don't know what heating is, right? But in America, if you can ship that to America, you can sell bags of wood pellets for $4 a bag.
Okay, the gentleman at the back. Anyone who can pass the mic?
Hello, Marcin. Glad to see you again.
Thank you.
Sorry. I think sometimes the challenge is not only building it or imagine I have the know-how, the materials, a bunch of people, and everything to build an autonomous car or a house. But the problem is how to get the license or the approval from the government. Okay, and when I built it, they have to come in and inspect the safety and
Yeah.
everything. Okay, and then they will ask me, who am I? Mr. ABC or XYZ. Okay, how can I get this kind of approval licensing from the government? That is going to be very difficult. And perhaps you have encountered similar problems. How do you deal with it?
Yeah, good question. So first of all, we are the government. We are the people. No, where we are, believe it or not, sweet Maysville, Missouri has no building codes. It's one of the few places in America. I mean, there's actually like maybe 40 different counties in America. So rules are not there everywhere. But if you're going to get into rules, yes. For example, for the CDECA home that we're building, we will provide like all the engineering stamps and certification and calculations. That's just part of the documentation that we have to do. And otherwise, yeah, you have to deal with the officials. But once a certain model is approved, like for example, say in Hong Kong, you want to build our floating, in the bay, floating house or something, Once the first unit gets approved and goes through the zoning or legal process, then also it's facilitated for the next people. So there's always going to have to be a pioneer. And otherwise, you know, you have to move to a place which has less rules or something. I don't know. Yeah.
All right. Any questions? Any more? Yeah, great. We have a lady.
Nice seeing you today, Martin. And thank you for your very thought-provoking talk. And my question is not about open source ecology as much as it is about you. And at the beginning of the talk, you mentioned that you got acquainted with meditation during your doctoral studies. So I'm curious, how does meditation shape you as a person and also as an innovator? And does it have to do with your decision to drop out from the graduate school and to be... Oh, sorry. Yes. So does it have to do with your decision to become a social innovator rather than a scholar in the ivory tower?
Yeah, absolutely. I did drop out, even though I didn't drop out. But absolutely, the change is profound. So 2 years ago, Rinpoche spoke. I mean, all that stuff that he said, it's true. Listen to that talk. But yeah, it's absolutely, that's changed my perspective fundamentally. I was essentially able to break away from the system, kind of like the constraints, like, oh, you have to do things a certain way. Like in summary, I actually like to say that before I start to meditate, I was an average person. I will not say that I am average now. And that is the kind of focus that I gained from meditation. So yeah, the changes are absolutely profound, that I must say. It's just an ability to have a different focus and kind of break through the noise in society to see what's more important, kind of like connecting to the infinite computer and all that. So yeah, definitely recommend it, like if you have a way to do it. Like part of the, as I mentioned, in 2028, I'm going to retire again. Part of it would probably be teaching meditation, like helping people to access that in a better way. One thing I can say maybe for meditation, if you want to learn more about it, there's a good group to look for is mindvalley.com. So in America, I think that's pretty popular. Mindvalley is a place where, someone hear that? Who has heard of Mindvalley here? Yeah, I mean, a few people. I listen to that, but yeah, that's a dimension that we absolutely do not learn anything about in school, yet it's so fundamental. So in school, you do not learn how to learn. You do not learn anything about your psychology or your superpowers or meditation, like all those soft skills pretty much are completely neglected. And a lot of our parents, I don't think, in the older generations, I think, people are less familiar with like more of the soft, new agey kinds of stuff, so-called. But I think it's becoming more accepted and definitely recommended, and it will change your life. I mean, it's definitely been huge. Yeah, I might be sitting in a cubicle somewhere if that didn't happen. So, yeah. Great question. Yep. One more question from the ladies, though. More ladies. They ask good questions. Ladies first, please.
I'm sorry. No. Just based on the picture we saw, that is the team of engineers building the first house, I guess. Like all of them are men, but rather, apart from the women holding the baby. That's what I spotted. And then, are you planning to like take any efforts to bring more girls in?
Oh yeah, that question comes up. So yeah, I think we have to do that. We did reasonably well with the people we trained this year. So the two people, we have a 50-50% gender ratio. So one lady, one guy right now. But so Katerina, my wife, she talks much more about it, and she's that's an issue for her. But I think it's something that we should consider. I haven't considered about like very specific steps, but maybe if you join our team, we can help us out on that. I don't know. We're very open to it. Yeah, we want to have more gender balance on the team. Yeah, as you notice, I mean, yeah, all guys. So, yeah.
All right, another guy. Here, in front of
Yeah.
Okay, thank you for your talk. And I have a question about your title, the open source ecology. I want to ask, to what extent is the open, do you mean? I mean that when you, even though you are like holding those workshops, finding a lot of people to make your own open source hardware, but you still need the raw materials or the supplies that you mentioned. You need the supplies from mainland China.
Right.
So I want to ask, to what extent that the open can be open to?
Great question. And what you're referring to is what we call technological recursion. So right now, we buy all the parts off the shelf because we cannot make them ourselves. But as time goes on, we go to the full technological recursion. That means we start making the parts and the components up to the level of the materials. So that's actually in a set. So by 2028, that means we have achieved, one, the ability to melt steel with an induction furnace to take the waste metal stream and turn it into steel parts. And even further than that, aluminum extraction from clay. So that's a feasible process. You can take clay, which is aluminosilicate, and you can extract aluminum out of that. So that'll be like the final proof that you can build up to modern civilization from the raw resources of just about any parcel of land. You will have clay in many, many places around the world, so you can get up to even crazy things like making advanced industrial materials from very common materials. Like, what is your computer age? It's sand, right? And we're aiming to show that that's feasible on a much smaller scale than we ever thought possible. So that will happen by 2028.
Oh, really?
With your help.
I hope this can be still keep open. All those procedures from the lifetime cycle of those products.
Absolutely.
Because right now we are enduring those capitalists. Yeah, those entrepreneurs, they are selling products to us. But if we can build the products from raw materials, I think it's really, really good.
That's a game changer indeed, and that's why this can be so profound. The deeper we go into the system, the more power it gets. And that's why we use the word ecology at the end. So it's an integration. One, it's the ecology of different products that work into a harmonious whole. And the ecology also refers to the integration of human and natural ecosystems. But yeah, it's a good question. Yeah, and the power you get from that, from being able to do that, I think is transformative to the point that it will change the economy upside down. And that's the kind of reality that I live, and that's why I'm so excited about this, because I see this very clearly. This is just a matter of time. Because technology is absolutely getting better and smaller on the scale of things. Like, things are getting smaller, and more advanced technology is happening all the time. So at this point, at the junction of the internet age, we just have unprecedented ability to change things around us. Yeah, and it's becoming, and the access is getting easier and easier. So if people understand that, that would be a cultural shift in the world. Yeah.
Yeah, I think that's why I made the remark that when you talk about these technological changes, you're actually talking about social relationship changes as well.
Yeah,
you don't
absolutely.
Need to wait until the end of the completion of your sets to see that happening. They are intertwined.
Yeah. And the idea is that it's like the technology is, we look at it all like a prerequisite, because if people cannot make a livelihood, yes, absolutely, it's about changing the human, because without changing human consciousness, we cannot do any of this. but we're approaching it from the material world because that's easier to access. So it's easier to teach someone something by putting food on their table than trying to help them meditate if they're hungry, right? So that's our approach.
Great. Any other questions on two sides? We have lots of questions here. Great, another lady.
My question is kind of a follow-up question of that lady. Other than meditation, besides meditation, what kind of, what books, what philosophers, or what education that lead you from there to here, or your family education, any influences you have?
Yeah. Yeah, so some seminal works are things like, so there's Schumacher's Small is Beautiful, Gandhi's autobiography about self-reliance and production by the masses. There's a book called The Second Industrial Divide by Michael J. Piori from MIT, who wrote about the idea that it's a book that talks about that smaller scale, flexible manufacturing is just as viable as this massive centralized production. So that's a definite seminal book, and others. Like I look at like things like Buckminster Fuller. That's kind of like this techno-utopian vision. But people like Buckminster Fuller, like when I kind of critique that, it's like he was not at all open source actually. You know, like you guys know Buckminster Fuller, right? Maybe you heard that. And then if you want to learn about the history of how the struggle for democracy and the role of technology in it, a great book on that is actually called The Democratic Surround. I recommend that one. And another book along the same lines, From Counterculture to Cyberculture, Why the Hippies Failed and how we can do better in the future. So a lot of different learnings. I need to, plus my book coming out like in a year or two. It's going to cover all of that. but yeah, it's definitely, it's like, I must say I have absolutely nothing new to share. This is all, I'm just reading stuff, picking stuff up, and trying to synthesize and integrate. So I don't try to say that I invented any of this. I invented nothing. I try to look for ways to put things together. That's all. And that's why I think like patents are ridiculous, because if you patent something, you're standing on the shoulders of giants. You're making like a little change upon this immense body of knowledge. So for you to claim that it's your own, it's kind of like ridiculous and egoistic in my view. So that's what I just think.
Well, putting things together differently is also a creative process, I guess.
It is a creative process, yeah.
Right. Okay, another lady, very good.
Again, thank you very much for your very inspiring sharing.
Thank you.
I want to know, in what way would you want to change the education system or curriculum? That may be happening in 2028 vision. That's the more personal and socio-cultural transformation, I would say. But I'm very curious about how, as an engineer like you, has transformed to this personal well-being focus. So basically the question is, how would you suggest the change on education system and curriculum?
Yeah, I mean, I was very much dissatisfied with what I got in my education, and the thing that was missing for me absolutely was the practical aspects. One is the drive at which education goes. A lot of it is kind of towards keeping these things the same way. It's very theoretical in many ways, so I would definitely do like what we're trying to do. We're actually developing an immersion program that evolves to like a full university kind of a degree. Like, we're going to create that because I think the part that's really missing is the hands-on applied skills, the integrated aspect, the idea that we are learning to be generalists rather than specialists, because if you're a specialist and you do not know how things connect to other things, you can only cause trouble in the world. And that's kind of what happens a lot today. if you don't know how your thing affects the next system, you cannot be responsible by design. So we need to train people that are much more integrated and broad in their thinking, and also people that work with their hands and just applied things, where the assumption is, okay, how are we making the world better for everybody? So a definite ethical focus on that, like just the real, like the stuff I talked about, self-determination, the purpose, the autonomy and mastery. And I would say more of the entrepreneurial viewpoint, which is really about responsibility other than waiting for somebody else to do it, like the government or whoever else is going to fix things for us. No, it's our responsibility. So yeah, that'll be the plan, and do it a lot through being involved in like productivity of real things, like grow things, grow plants, produce objects, and then be a philosopher on top of that and all that, and whatever. So yeah, integrated humans, idea of integrated humans. Yeah.
Yeah, I think that's a great point. Sometimes we forget that we are born as makers as well,
Yeah.
And we just study, right? So GE, general education, let us do something together. Any other questions?
Any other ladies? There's a lady right there.
Great, another one over there.
My first step is to start encouraging ladies to ask questions.
Thank you very much for sharing. And to be honest, I have no background knowledge about engineering or coding or programming. I just know how to draw circles on JavaScript. So how could people like me start to learn about engineering or to do stuff like you do? That's my question.
Yeah, so I mean, we're trying to get there where we teach people, just average people, how to do that. So doing things like participating in our workshops is one way, because we're not assuming any skill on the part of the participants. We take people from scratch and we teach them the skills. It's just something that you start doing, but the first thing that has to click in your mind, you have to have a purpose. Like if you can convince yourself, okay, I need to do that, that's very important to me, then you will. You have to have a mission behind it. Like for me, actually, I must say, like at one point, now I was studying this engineering stuff, but it was all theoretical and stuff. But I was walking down the street and I looked at some cars, and it's like, okay, cars are super polluting. And I said, hey, one day I'm going to build them. And at that time, it was a radical proposition for me because I had no practical skills. And now, that's what I'm starting to do. But it has to start with a deep conviction that it's desirable for you, and then anything else will follow. So, but also like practically for our stuff, we're putting together two main packages. One is the ability to design in CAD software. So basically, where you can draw circles. Well, you can draw circles within CAD. You can combine them with squares and other primitives and start making real physical objects, because that's what physical objects are, just a bunch of primitives one on top of each other. And so that's FreeCAD. We're preparing like a two-hour crash course on that. Now the other thing to collaborate, there's a big package that's not the technical part, but how do you work together with large teams? Like how do you document everything? How to use the wiki and other tools of being aware of how do you, like what are all the different categories of information? How do you record that and use that on our wiki or other things? So that's like the collaborative literacy training. So there's two things. One is like the technical CAD, like CAD design, mainly that part. So you can convert a conceptual design into real technical CAD, which means it has got like real dimensions and specifics on it. So two sides, but yeah, it starts with your recognition that you want to do that. Yeah. Yeah.
All right. Okay, that gentleman over there. The gentleman over there.
Thank you for your speech. And after hearing this, I've got a feeling, I'm not sure, whether there is a limit for this open source, because we can build a tracker, we can build a 3D printer, we can build a house, but can we build like a smartphone or laptop? Because it's the product of the combination of hardware and software, and people, ordinary people may not have this skill, or they don't have the knowledge. You need more time and to cultivate them. So is there any limit to this?
I don't believe there's a limit, because just like we can use a computer right now, you don't know what's inside a computer yet you use it. Think of this, that each technology, I try to point out that you have a breakdown of a technology into modules and sub-modules. If you can do that effectively, you can get down to more primitive elements that form a construction set. So if you have, like for example, you don't need to know how the internals of like a microprocessor work necessarily to use your computer, nor would you necessarily need it to know how to add other components to it. So the idea is, if you have well-interfaced components that you know what they do, you can make them into more complex things, and you build one step upon the other. So if that kind of level of functionality is documented and available to people, I mean, that's how the most complex things are made. Like, if you design a car, say there's a car designer, he doesn't necessarily have to know exactly how the internals of the engine work. It's like you build upon components that you already understand. Like, I don't think there's probably anybody that understands how every single circuit inside a computer works, right? I mean, the people who design those computers work like they treat certain things as black boxes and other things they might understand, but things are too complex for us to understand everything. So if you think along the model of construction sets where you have blocks of certain functionality, you can conquer any kind of technology. And I saw that first with things like the tractor. I mean, it literally is like that box with wheel drive, some controllers and stuff like that. The skill comes in just understanding or recognizing that there's a breakdown like that that is possible. And you have to understand the function of each thing, but you do not have to understand the insides of that necessarily. And that's how complex technology can be made. So I don't think there's any limit to that. Like, if you mention a cell phone, there's a project out there called Phone Blocks that, you have different modules of a cell phone. You just put them together, and you can actually build your own cell phone. So it's, I don't believe there's a limit.
But those gadgets, the small gadget in those, like, I don't know how they call, but those high-tech things need to be outsourced to those other companies.
Yeah.
In the end, not by ourselves. So in your view of future, it will be like we have company doing things and we have individual building things, right? So they are parallel, not contradicting.
What's the question? What is the question? I missed the question.
It means that in the end, we still have the company who deal with those small gadgets, and so we are not those companies are not disappearing. They still survive. They still exist, right? Okay.
Yeah. I mean, but you can do it different ways. Like, just like before, to do things like that a 3D printer, for example, could do right now, even 10 years ago, it was beyond the imagination of most people. So think of the Star Trek replicator, that nature of technology is really coming. So yeah, it could be a company that does that, but why not, like in the future, you have like a desktop machine that prints circuits using technologies that we don't know today. I mean, I think it can happen. We don't know what the limits of that are really,
Thank you.
Yeah.
All right, I was told that we could only ask a couple of questions. So we do have Donna here, and
Hi, Martin. Thank you. Just a very quick question. Can you describe the future you most want to see in 2028, maybe?
Future I want to see in 2028, well, we're just going to finish our stuff, so the applications are going to come forward after that. But no, the future is a much more integrated world, like where the distinction between like big city and country is kind of blended more, where everything is more ecological, and we're blending into nature with without leaving like all these biological deserts and just areas of poverty versus wealth. I think an ideal state would be where a thing which is much more in balance, and like the humans have regreened like much of the deserts. Like deserts are largely human created these days, starting from Mesopotamia, which used to be the Fertile Crescent, which is now the deserts of Iraq. I mean, the Sahara Desert. I mean, it's all human creation. So in the future, we could take an active role of regreening our entire Earth, like putting all that carbon dioxide back into plants. So just thorough regeneration, like on the environmental side, but on a human side, reintegration of the human. Because we're broken as human beings, we're fragmented, and mostly a lot of psychological issues of alienation and things like that, or depression in many countries, advanced countries. So fixing the human, fixing nature, and just making things more balanced, like a lot of people talk about like, oh, how are you going to do it in the cities? Like, oh, I'm not going to live in the countryside. But I think at the end of the day, it'll be like a nicer balance of where if human settlements are more integrated with nature, it doesn't have to look like a massive, nasty city. Like, I think Hong Kong is actually pretty nice, where you have a lot of this vegetation happening everywhere in addition to the built environment. So I would see more of the world like that. But maybe it could be better, but yeah, more integration.
Well, because he's staying in CHK all the time. Well, I'm really very honored to be the moderator. I have to say, I'm also the director of the Urban Studies program. We've been like advocating ecological and humane urbanism all the time. So you have to be our honorary advisor to the program, because everything that you've just said, fits so well with our philosophy. And I think, yes, it's this idea of like we need this right to knowledge, that can be modularized, and that we can use bit by bit, to build things, to solve our daily problems, practically, having that ability, and also learning how to collaborate, this collaborative literacy, another soundbite which I love, because I think with that, if we really have that literacy, then we can build a very different world from what we can see today. Because the world that we are in is talking about, everything is about, I, or like money or profit, but we are talking about coming together and solving problems together so that we can make one another's life much better. And I think that is a great idea. So shall we all give a big round of applause, to Machin. So thank you, and have a great evening.
Thank you all. It was great. Yeah.
Sorry, it's not yet the end of today's lecture. Thank you, Dr. Jakubowski, and thank you, Professor Ng. And as a token of gratitude and appreciation, we would like to present our honorable speaker a souvenir. So please allow me to briefly on this gift. The souvenir is an upcycled speaker made from a waste 1.5 liter plastic ink container, and it's designed in Hong Kong. Yeah. Yeah, it's a speaker for our speaker. Yeah. Thank you. And Dr. Au, please stay behind as we would like you to present another locally made souvenir that we have chosen from a social enterprise run by New Life Psychiatric Rehabilitation Association to our moderator, Professor Ng. Professor Ng, please. Okay, one more photo. Oh, three of you together.